A very warm welcome back to Chip Chat. I'm Mehavani here with Mr. Shivakumar to talk about a very interesting topic. As a viewer, you might have wondered how the chip works, what are the components of a chip. But have you ever wondered about this hidden world that powers our digital age? Well, today we're going to address just that. We're going to delve exactly into the heart of semiconductor ecosystem and understand what exactly it's about. So let's go into our first question then.
Good.
So our first question is, what exactly is the semiconductor ecosystem and how it functions as a collaborative entity?
To understand the semiconductor ecosystem, you need to understand the semiconductor supply chain. Semiconductor supply chain is very complex. It involves various companies like fabless IP companies, EDA companies, electronic design automation, design services companies that provide engineers as consultants. It involves chip makers, companies that make chips. We call them as IDMs, integrated device manufacturers. And whatever the chip they make, eventually it goes to foundry. Foundries are the companies fabricate the chips. To fabricate the chips, they need various things like specialized chemical materials and machines. That involves various kinds of companies. So it's pretty complex. For example, iPhone 14. To realize iPhone 14, Apple needs a complex SoC called A16. It has more than 16 billion transistors. Let's take this as an example. So Apple has to design this complex SoC. It falls under OEM, original equipment manufacturer. Any company that makes devices like smartphone or laptops, we call them as OEM. They also have their own chip design center, very similar to IDM. Companies like Intel, we call them as IDM. Now Intel is expanding their business into foundry. That's different. So IDMs, integrated device manufacturers, produce chips. Now, as OEM, Apple wants to make their own chip. They don't want to get chip from someone else and then use the chip as it is. Now, to make this chip, what they do is they buy components from various fabless IP companies. I'm talking about A16 SoC. This SoC needs various things. I already explained in one of my previous episodes. It needs CPUs, it needs GPUs, it needs image signal processor, like these various components. Each component is called as IP, intellectual property. So there are companies, we call them as fabless IP companies, produce all these IPs. Companies like ARM, they are specialized in RISC processor. Apple uses ARM's RISC processor. There are companies like Sci-Fi. There are companies like Synopsys. They provide various kinds of interface IPs like USB, Ethernet. You need all these components to realize the chip, A16 SoC. So they need IPs. They get all these IPs from fabless IP companies. And then they also need software tools to design their chip. If they are going to get hundreds of IPs like CPUs, GPUs, all the components that I mentioned, right? Finally, they need to integrate all these components to design the chip. They need to create this complex SoC. To design the chip, they need various kinds of tools. We call them as EDA tools, electronic design automation. Because the chip is complex, you can't think of doing this manually. You need some kind of automation. So they use various kinds of tools like simulators, synthesizers, design for test tools, or physical design. There are various things like floor planning, placement, and routing, and you need tools for verification like static timing analysis. There could be hundreds of various tools. That's how basically we define the flow, ASIC design flow. We consider the chip as ASIC, application specific integrated circuit. A16 is ASIC. Why we call this as ASIC? Because you use this chip only for smartphone. You cannot use this chip for some other application. So we define ASIC design flow using various kinds of EDA tools. So EDA companies are the companies specialized in creating the software tools. So you need IPs and then you need software tools to design the chip. Now, you also need engineers. It depends on the complexity of the chip. It depends on the projects. It depends on the scenario, market scenario. If the company is going to be super busy with multiple projects, then they may not have enough engineers on board. Then what they would do is they would approach services companies. India is popular for design services. You might be familiar with services companies like Infosys, Wipro. What they do, they provide engineers as consultants. They provide workforce to the product companies. So Apple outsources their design work to some of these services companies. So the engineers go to Apple as contractors or consultants, and then they will be part of their design work. They work along with Apple's workforce engineers, and then together they design the chip. So to design a complex chip, what we need is we need IPs from fabless IP companies. We need EDA tools from EDA companies, electronic design automation. Also, we need engineers. Engineers are the primary resources to design the chip, right? And then whatever the chip they design, A16, it goes to foundry like TSMC. It's based out of Taiwan. TSMC is into manufacturing, chip manufacturing. They fabricate the chip. Eventually, they produce silicon, the actual chip, and then the chip component comes back to Apple, and then they design their own motherboard for the smartphone, and that's how they make the smartphone. Now, if you consider there is a supply chain. For the chip makers, they need IPs, EDA tools, and engineers, and then they design their chip. The chip goes to foundry. It depends on the foundry, and foundry needs some machines and materials. It's very complex. It involves various players. This is how we produce chips, and this is how basically we use chips to create various kinds of devices like smartphones and laptops. This is how the supply chain works, and this is how I can explain the semiconductor ecosystem.
So, as a student, I want to know what is the scope of the semiconductor industry? What is the future of the semiconductor ecosystem in terms of market trends, technological advancements, and just societal impacts?
As I explained, semiconductor ecosystem is very complex, but the thing is, whatever we do in the digital world, everything depends on the chips we produce. Though it's complex, actually, chip has become the backbone of digital world. Currently, if you look at the market value of semiconductor industry is more than 600 billion US dollars. And we are expecting this industry to grow as $1 trillion industry by 2030. What this means is there are upcoming technologies like artificial intelligence, cloud, 5G, autonomous vehicles, electric vehicles. All these technologies depend on chip design. So much is going on in this field. How we design chip, new kinds of chips. Now you look at A16, smartphone SoC, that itself is very complex. It has more than 16 billion transistors. Now, the complexity is in the range of billion transistors, right? So when I say A16, 16 billion transistors. So the revenue is billion USD. 600 billion USD. But if we want to become a $1 trillion industry, I think the complexity of the chip should be trillion transistors. So the revenue growth of this industry depends on the power of technology, how the technology, VLSI, very large scale integration, is going to evolve further. That's how I visualize. As an engineer, I visualize this way. Now we are able to make chips like A16, billions of transistors, but in future, if I am going to have the access of a powerful technology that can help me to produce chip with trillions of transistors, I think that's where we are going to make 1 trillion USD. And that's how the industry is going to grow bigger and bigger. And this is the future of semiconductor industry.
Interesting. I want to know how India contributes to the semiconductor ecosystem. What are some of the key initiatives or activities that India takes that impacts the global semiconductor industry?
Very good question. We are very popular for engineering workforce. Then you need to understand our academia. If you consider academia, there are more than 2,500 engineering institutes. So we produce millions of engineers. There the challenge is whether everyone will be good for chip design? Not really. Top 10%, they will get into core industry. If I consider the core industry, predominantly IT services, companies like Wipro, Infosys, they hire a lot of engineers. Then remaining engineers in the range of, I would say, 5,000 to 10,000 engineers get into chip design. So that's very, very less. That's where we are looking at how to improve the number from 10,000 to at least 1 lakh. Whether we would be able to produce 1 lakh chip designers successfully every year. That's a big number. You need to consider the gap from 10,000 to 1 lakh. How are we going to do that? That's where Maven Silicon is trying to emerge as Center of Excellence in VLSI, trying to bridge the gap between academia and semiconductor industry. Currently, the challenge for electronics engineers is to have the skill set needed for the semiconductor industry. Are they really competent to work on complex chips? And what is really needed for them? And what is really missing in the curriculum? Today, you come to Maven Silicon, actually we explain how they can understand smartphone, fundamentally how it operates, why we need system on a chip. This kind of big picture is required. At the same time, chip design doesn't happen like the way we enjoy storytelling. You have to be a hardcore engineer. You have to be a geek. You need to understand fundamentally how things happen in terms of binary. That's what I have been explaining in this series. So they should be competent enough to deal with the complexity of VLSI. That's where we look at how to make these engineers skilled. So our focus is producing skilled VLSI engineers for the industry. So we are collaborating with academia. We are working closely with thousands of engineering institutes. We are trying to give them awareness. And also we focus on attracting these engineers to the semiconductor industry. That's a very big challenge because the intelligent engineers look at how fast they can get into the industry. So they prefer software than chip design for two main reasons. They are attracted by the salary provided by the software companies, software giants like Facebook, Microsoft. Naturally, that happens. For anyone who is looking at building a long-term career, they would be attracted by the initial salary, which we need to look at how to create that awareness, right? We are trying to explain them like, while starting your career, you need to ask yourself, what's your cup of coffee? Whether it's software or hardware. In hardware, what do you want to do? VLSI or embedded systems or PCB design? It could be anything. Go by your interest. That is the primary thing. Don't look at only salary part. So how can you start your career? How you are going to start your career? That is going to define your long-term career. That's what we look at. So that's challenge number one. The other challenge would be like dealing with the complexity of VLSI naturally. For young engineers, it looks like puzzle, a big puzzle. Then they shy away from touching this piece. Oh, chip design, pretty complex, ASIC, FPGA, but I enjoy doing software coding, maybe Python. I enjoy creating mobile apps. Then we have to excite them. Hey, how about creating a smartphone? Tomorrow, if you are going to create something like iPhone, how about that? That's going to be very exciting. Don't you think so? That's what actually we try to do. So what we do is we provide foundation courses to these engineering institutes and we try to give them big picture. We try to excite them so that we expect them to choose VLSI on their own, which is very important for me. As a founder of Maven Silicon, what I really expected from the engineers community, you choose VLSI if you like it. So my question is whether VLSI is your cup of coffee. You like it, you come to me. Then I will make you a great chip designer. That's how we approach. So with respect to your question, what is our contribution? Our contribution is producing great engineers at this point of time. Also, we are looking at how to grow within ecosystem, right? We are also looking at growing in the fabless IP space. There will be IP startups. Along with that, the government is initiating many new things like allocating funds for the fabrication, right? So our Indian government has allocated billions of dollars, more than 10 billion USD for the chip manufacturing. And that's how the future is going to happen. That's how I visualize the future. It's going to be great for chip design.
So, how exactly does the collaboration of academia, industry, and research institutions add on to the development of the semiconductor ecosystem? Like how you mentioned that Naven Silicon is collaborating with academia. Sime, how does this collaboration add on to the development?
Collaboration between academia and the industry, right? So as I mentioned, Naven Silicon is trying to bridge the gap between academia and industry. What that really means is we want to collaborate with academia, we want to collaborate with industry. We are going to be like catalyst. So your question is how this collaboration can help us to grow. Can help us to grow as an industry. See, what the industry wants, skilled engineers. Then we need to fill the gap. The big question is, how can we make the engineers qualified for chip design? We don't want to lose good electronics engineers to the software industry. So basically, we are trying to compete with the software industry, right? So we want the top talented electronics engineers. When I say electronics engineers, truly passionate engineers who are truly passionate about chip design. We want them to choose VLSI. So collaboration is really required. Experts from the industry, if they can reach out to these young engineers and explain all these beautiful things like how we make smartphones, how we make laptops, and what is supercomputer, and why VLSI is very essential for the next generation of defense technologies. Now, the entire world is talking about chip war. And what is chip war? It's nothing but AI Cold War that's happening between United States and China. And why that is something important. What US is trying to achieve and why this is something very, very important to the growth of semiconductor industry. And what happened during COVID? There was a supply chain disruption. All these OEMs, original equipment manufacturers like Apple, they didn't get chips on time because during COVID, especially during COVID lockdowns, foundries were not able to produce chips. They had to shut down their operations and OEMs didn't get chips on time. That's where everyone realized, wow, chip is something very important. I can't make my smartphone. I can't produce my car, BMW cars. They had their own challenge. All these luxury vehicles you consider, they use hundreds of chips. Without chips, they can't make luxury vehicles. So everything was like on hold. They were not able to proceed further. That's where the entire world is looking at like how to balance this supply chain. Currently, what's happening is we get more than 90% of the chips from Taiwan. Foundries like TSMC, they produce most of the advanced chips. So the entire world depends on one country, Taiwan. Now, every country is looking at like, okay, how can we work along with this country to produce more chips? We are trying to balance the supply chain. That is the initiative. That's what we realized during COVID lockdowns. Now, US is producing only 10%, so they are looking at like how to produce at least 30% of the chips by 2030. And then while this is happening, India is also becoming ambitious. We haven't done much in this space with respect to manufacturing. Everything is new to us. When there is an initiative in the United States, India is also looking at like, okay, can I join my hands with the United States so that I can understand a little bit about this manufacturing ecosystem and then I can do something in my country that will help for the future of semiconductor ecosystem. That is all about balancing the supply chain. So if the industry experts can reach out to these young engineers and explain what is going on in this world, something like chip war, and these engineers can understand why chip design is very, very important for every country. Without chip design, the countries cannot dream about making the next generation of defense equipments, the next generation of defense technologies, the next generation of space technologies are the ones going to decide the future of the country, whether the country is going to be considered as world superpower. That's what the United States is fighting for. That's what China is fighting for. And that's what India is trying to be very ambitious like. Can we be the best among all the countries, right? So technologically, if we want to be very powerful, we need to have our own ecosystem. And for that, the primary thing is workforce. And we have everything available. We are good at producing engineers in bulk. We produce army of engineers. That's our strength. Now, what we need to look at is just one thing, how to improve the quality. When I say quality, skill. How many engineers will be good for chip design? If we can achieve that, I think we are going to be good. And how Taiwan supports the entire world through manufacturing the same way, we can also support the entire world producing good engineers, highly skilled engineers. That's how I'm visualizing the future.
Right. I think we've come to the conclusion of today's episode. I think it was a very, very informative conversation that we've had today. It's given me an exact idea of how the semiconductor ecosystem runs. If you're just a student or a working professional, or you're just simply interested in technology, I think all of us would be a part of the semiconductor industry somewhere. And I hope today's conversation has somewhere sparked you to become a VLSI engineer and be a part of the semiconductor industry.
It was a good discussion. Thanks for having me on this show.
So until then, see you. Take care. Goodbye.